3. And this, I thought, was very interesting stuff. The web is just very, very complicated. And I know some web designers, they say that a good web designer knows many techniques and then doesn't use them. That was the old wisdom. The thing now these days, and most good web designers know a lot of languages, like 30 or 50. I know a guy that just has a Rolodex. He shrinks down all his certificates to 3x5 to put them in a Rolodex. It's just ridiculous. When it was all started in the 70s, there was one language called BASIC and a couple others like Fortran and COBOL, and we would discuss about which language was going to win, and then all the others would go extinct. Like in the human world, English pretty much won. And pretty much everybody, all the documents are written in English, and the other languages are fading, and even in other countries that don't speak English, they pretty much all have to learn English because it's become kind of a standard. But this did not happen on the web at all. Just an endless proliferation of languages. It just turns out to be amazingly efficient to just make up a new language for everything you do. So anyway, HTTP is where it all started. This was the original World Wide Web, where it's just this idea of making something better than printed documents. That was the idea. Instead of having a book where you have to pretty much read the pages in order, and there's an index, and there's no way to suddenly stop in the middle of a sentence and decide you want to go to what that one word has to tell you, they're going to have this thing where you can have a multiply connected bunch of pages where links on one page will go to another page, and you can just stop halfway through a paragraph and Google some phrase and go there and read about something else. And so you end up having an experience that you choose, not the experience of every page in order the way the author wrote. So that's the game. And in order to make it work, they made it a connectionless protocol. You send a request, you get a response, and the server forgets all about you until you send another request, which is fine for the original purpose of the web, which is just to put up static pages like pages out of a book. The problem is, if you have an email page, it's not okay if everybody's seeing the same page of email. You want to see your email, and you don't want anybody else to see your email page, so a stateless connection is not going to do it. But anyway, there's the HTTP, has these HTTP requests going up. It's just a bunch of text. The get is the verb. Then you have a URL. This is /CSS, family equals Roboto, and that stuff. Then you have HTTP / and a version number. Almost everybody's using HTTP version 1.1. And the rest of this stuff is optional except for the host parameter. If you're using HTTP 1.1, you have to have the host parameter. But you may have all these other connections. What you must have is the verb, the HTTP number, the URL, and the host in most cases. The referrer, spelled wrong, and officially that's the official spelling, however, well, these things don't slip by the IEEE that often, but this one did somehow, is the page you came from. And this is used, you could use it to track what ads are effective, and you can use it as an extremely weak security measure to try to stop people from jumping directly into the middle of your website and only let them come in from the previous pages you expect them to be on. The problem is anybody can forge the referrer header. They can forge any of this. It's just plain text. It's not encrypted. It's not signed. You can just put anything you want in there. There's no way to verify any of it. I was talking to people in my family. They're upset because they're getting phone calls from people. And when they look at the caller ID and try to call them, they can't get through. And I said, you can put anything in the caller ID you want. It's just like the from address in an email. It's an arbitrary tag. It's not verified at any level. So you can just make calls that appear to come from the White House or anybody. And the same thing's true here. You can just forge any of this stuff. So you can't trust any of it. So you can't really use it as much of a security measure. Anyway, so that's the host is the host name of the server. So typically, the URL that you might type in an address bar is broken up into two pieces. Like here, the host is fonts.googleapis.com, and then you'd have /CSS. So the host parameter has the domain name, top level domain, and server name, and the rest of the URL is in the get parameter. All right, so there's another HTTP request. So if you want to label your machine somehow to keep track of who you are because you've logged in, and now when you go to future pages, I want you to see the personalized page for you, like your email. I have to put some kind of persistent parameter on your machine, and the most common way to do it is with the cookie. Netscape invented it as the magic cookie for this purpose, to add statefulness back to HTTP. So the cookie is just a series of name value pairs, sequence version equals 2, groove insights equals this long number, and so on. And if you use cookies correctly, when someone logs in, you just give them some horrible long random number like that means nothing to anybody, except on your server, there's a table that says that number matches this user. And now all requests with that number will show them this person's email, and now you know who they are. So that is a way to keep track of who people are. Of course, if you use HTTP and not HTTPS, then anybody that sniffs can steal that cookie, and that's cross-site request forgery, and that was an extremely powerful attack that would work on almost all web services until about 3 years ago, when Google led the way to actually going 100% HTTPS. And if everything's HTTPS all the time, then it's all encrypted, and it is no longer so easy to steal it off the wire. It's not impossible, but it's a whole lot more difficult. So that's the game there. The HTTP response will come down. It has a header too. The main thing it has is a status code. HTTP version and a number up there, 200, okay. The number is all that matters. The alphabetical thing after it could be changed, and browsers never use it. It's only there to help humans understand it. 200 is the most desirable one. That means you asked for something, I found it, and here it is. So after the header, there's then 2 character terms, and then comes the stuff you asked for. So this stuff is application JavaScript, and down there you have jQuery and other kinds of JavaScript coming out. That's the game there. Then you have, it also has a thing called a server header that tells you what version of what software you're running. This is also not used by any browser as far as I know. In principle, you could have a browser that knows that it's talking to Apache and somehow houses the page differently than when it's talking to IIS, so I'm not aware of anyone that does that. But you could, and it is considered a best security practice to take that server banner out or put a lie in there, because by default it tells you too much. It tells you usually exactly what version you're running of what, and that's just inviting attacks. So it's wise not to just put in something vague. Anyway, and you can now have set cookies there. So the HTTP response is going to do set cookie. It's going to set these values. This AMPMV40 is going to be set to that number. It's going to have an expiration date. If you don't set an expiration date, the cookie will persist only for this session, and when the user closes the browser, it'll be gone. If you put an expiration date, it will persist for up to years, up to like 10 years or something, and a lot of them do. This is one of the big security weaknesses, especially on mobile devices. Cookies typically last forever, like 10 years. And one of the fun things I did a couple years ago at DEF CON is if you go to almost any online service, I think Microsoft Office 365 and many others, when you log in, they give you an authentication cookie, and when you log out, they do not cancel that cookie. It continues to be valid, and even if you change your password, the old cookie still works. So if someone steals your cookie, it's actually more powerful than stealing your password. There's absolutely nothing you can do to keep that person out of your account except close the account and open a new one. It's kind of madness. And this was true of Chase Manhattan and Wells Fargo also when I did it, although they had a 10-minute expiration on cookies, but it was still the case that cookies remain valid even when you log out. The only thing a log out button does typically is delete the cookie out of your browser. It doesn't actually change anything on the server, so that cookie remains valid, which is mighty strange, but that's usually what it does. Yeah?
So, 2 questions. So if you intercept the cookie, even though you log out, then you would still be able to open up a session on
Yes.
like a banking machine.
Yeah, and that's deliberate because most people don't enjoy typing passwords on mobile devices. So typically you log in once and it just has a cookie that will last there essentially forever, and you'll never have to log in again.
And typically, cookies are still the same. Do they still like keep it like the 4 kilobit size? Like they keep them like small, because you know how. Like,
I've never seen them too big. I found out what the limit is. I know.
No, but it seems like they do, because you know how I ask you, like sometimes if you have like a super secure machine, they'll be like, oh, like would you allow, programs or websites to write to your hard drive? Because that's what a cookie is basically.
Well, it is, but they're pretty small, so they usually don't ask you.
No. It would be super secure.
Yeah, but they're stored in your machine in text files, in plain text. They're pretty easy to steal with malware and so on. Anyway, there are a couple of parameters that make them safer. You can set the HTTP only parameter, and that will make it so only HTTP can read the cookie, so JavaScript can't steal the cookie. And you can set the secure parameter, and then the cookie can only be set over HTTPS, which was there for this reason and should have been used all along, but bizarrely nobody used it until about 3 years ago. That's why we had an endless chain of theatrical tools like Firesheep, where you could just open it up in a coffee shop and it would steal the cookies off the wire, and you could just see this guy's Facebook, that guy's MySpace, this guy's Amazon, just go right in there and be in their accounts all the time. You could commit 20 felonies, enough to go to prison for life, in half an hour with this thing in any coffee house, and it was downloaded by something like 1 million people in the first week it came out. And the underlying vulnerability persists in many web services, but the big ones have got the message, like Yahoo and Amazon and Google, and knocked it off. Everything important is encrypted on those sites. Anyway, yeah.
So let's say that we log into this HTTP, not secured
yeah.
website, and we have this session in the cookie. once we log out and once we log in again, shouldn't be like a new cookie generated. that
You will
is
get a new
already-
cookie, but unfortunately, that does not mean the old cookie stops working.
Oh, okay.
The old cookie, see, the server doesn't keep track of anything. For all they know, the old cookie was your phone. And even though, and most sites will also let you log in from multiple locations at the same time and multiple devices at the same time. So that's why it's pretty dangerous to throw cookies around. And what Google did for a long time with Gmail was you used HTTPS to log in, so they couldn't steal your password, but then you switched to HTTP and they sent you the cookie in plain text. So what was the point of that? They don't get your password, which is important because people reuse passwords. So getting your password is a serious violation of your privacy, but they get your cookie, so they're in that account. And usually, realistically, once someone's in your email, they own your whole life because they can do all the password resets at every other site, and the password reset will go to your email. That's usually the single point of failure for anybody's online existence. Anyway, so Pragma, here there's a Pragma header that says no cache. That tells the browser not to cache this. Just for performance use, browsers will make temporary local copies of images and other things on web pages, and next time you go to the same web page, they will try to just show you the stored copy of that instead of downloading it again, to give you a faster response when your bandwidth is not high. And they can just send a simple request to the server and say, has this thing been updated since I last got it? And if it hasn't, then they don't need to bother downloading it again. But if you don't want people caching things, you can put in a Pragma header, and that instructs the browser not to cache it. Of course, you have no way to know if the browser obeys that command. And there are a lot of things you can make, like for example, you can put a robots.txt file in the root of your server, which tells search engines not to index it, and some search engines obey that request, and some search engines don't obey that request. So it is a thing to know. Anyway, and you can set a time to expiration, or you can set expiration to a date in the past to make sure it always reloads this. It never stores a copy. After the header comes two carriage returns, and then you have the body. And the body contains whatever's described up above. It'll tell you how it was encoded and what sort of data it might be. This is application/JavaScript in UTF-8, which is normal ASCII, and that's what you see there is some form of JavaScript, a jQuery thing. So the verbs, get and post, are the main ones that are important. There are a few others, but these are the main ones that matter to us. These are the ones that ask the server to do something, and therefore how most attacks get it. Get is the most common, where you just want to see a page or an image or something, you get it, down comes the image. You might have to send parameters, and if you do, they'll just go all in the URL query string. Now that means you can save them. If you save a favorite in your browser, it saves the whole query string, it saves the whole URL, including the query string. The URL is the domain.com, and the question mark with parameters is what they call the query string, because if you use it search engines, typically it's the query, so what you're searching for. So that means the get puts everything all in one line. You can see it right at the top of the browser, and it's stored in your favorites, and it's also stored in the server logs all the way along. So if you're putting something like a password in the query line, that's a bad practice. Even if you're using HTTPS, it still ends up storing copies of your information in places that are too obvious, like a server's log. So post is considered safer. Post does not encrypt anything by itself, but it does take it out of the query string and put it in the message body, so it is not stored in favorites and it's not stored in server logs. So it's an issue to know. Better place for sensitive data. And now if you send a post by tradition, now you could use any of these parameters to do anything you want. It's up to you to write an app, but the intention of these different types of parameters is that the get is just specifying like which page you want to see out of a bunch of static pages, the parameters, and the post is the parameters that are more sensitive, like your username and password to log in. So if you buy something, they expect the buy action to be in the post parameter, and that's why if you click the back button after a post request, it will send you this message saying, are you sure you want to redo whatever you just did? Because you might end up buying a second copy of this or something. And that's assuming that the developers use these methods as intended. You could choose to put parameters in strange places in your app. There's no technical enforcement to force you to use it this way, but if you do, the browser's automatically generated messages will be confusing to the user. So you can send a head request if you just want to see the header, not the body. You don't really want to download an image or anything. You just want to know like what version of the server they're using. Options shows allowed methods like put and get. And put is almost never turned on. Put would let you upload things right out of HTTP. I'm not aware of anybody using this for any good purpose. Anybody I know that lets you upload things, they have a more complicated login process because this is kind of nuts. Apparently there was some time when people just used raw HTTP to put things up. But
Everyone was nice.
yeah, back when it was all new. That's when they developed all these stupid protocols like Telnet and FTP that send passwords in the clear, because there was a time when there really weren't very many hackers and people were just glad that it worked at all and just had no consciousness of security at all, which is how we got where we are, because a bunch of our methods date from that time. So there's the URL. Here's the general parameter of URL. You have a protocol, // then a host name, which is a fully qualified domain name, typically server.domain.com or .net or something. Then you can have a :port. If you don't specify the port, the default is 80 for HTTP and 443 for HTTPS. But you can put things on other ports, and then you'll have to put it in the URL. And then you can have /files, /path, /file name. And then you have question mark, parameter equal value, semicolon, parameter equal value, as many as you want. And they call that whole mess there the query string. And this whole thing is the URL. And when you save a favorite, the whole URL goes in there. And if you turn on forensic logging in your Apache, the whole URL is saved for every request that comes in. That's the game there. There's another way to do it. You can use these RESTful URLs, representational state transfer. So instead of having a query string like this, make equals Ford and model equals Pinto, you just put it in the path like it was a folder name. Search /Ford/Pinto, and your application has to somehow know what part of this to interpret as parameters and what part of it to interpret as path. They call that REST. It contains the same information in a different form. Certainly confused me first when I started going to websites and seeing this weird stuff. All right. So these iClickers, you've got them. Turn them on. There's a button at the bottom. If you don't have one, grab one and leave your name behind. Just don't put anything valuable down there like passports or credit cards or anything. There's little pieces of paper to write your name on if you don't have anything expendable with your name on it. So turn them on at the bottom and then click A and then click E. You should see you'll see how this works. As long as it's listening, you can keep changing your vote. And when I stop the clock, it freezes. And if you get the most right, you get 3 extra points. So it can actually add up to a lot after enough classes if you keep on getting the most right. Anyway, so you should see some action voting. If the lights won't come on or it's dead, then let me know, and I'll change the battery. Just give it to me, and you get 1 point, because if that happens during the class, because you don't have a fair chance to win now. All right, so let's do a few of these. So stop that one and go down to a real question, which is, which method puts all the parameters in the URL? All right, looks like the answers are coming in. I think I'll quit at 30. Looks like you already got most of them. All right. All right, that's get. Good, a popular answer. All right. All right, which one makes the parameters less obvious so they will not appear in the server logs? All right, looks like I can quit at 25. I think the answers are in. All right, that's post. All right, good. The main ones we care about. The others are less important. All right, which one is always optional? Quit at 25. All right, user agent is optional. Header, server is not, but user agent is the one that really doesn't have to be there, and it can contain lies. Servers do actually listen to that these days because they need to know if you're using a phone or not. And you serve a different page typically for a phone than for a big screen because it has a better experience for the user.
So user agent is key.
Yeah, well, that's right. How did I get, oh, pardon me. Pardon me. User agent, yeah.
Majority's right.
Well, thank you. User agent. User agent is the one I'm thinking there.
Yeah.
Head, okay, thank you. Yeah, head is not even an appropriate answer. All right. All right, which one of these encrypts requests? Or is it more than one? I'll quit at 25. All right, C is the only one that encrypts requests. You might imagine that some of the others do, but the colon tells you the port number. This is an insecure server running on 443, and this is a secure server running on port 80. You can do that. It's kind of screwy, and normal customers won't appreciate it, but the only thing that matters is this S here. That's what makes it use HTTPS, which is a much more complicated protocol with a 7-way handshake and exchange of a certificate verified by a third party. It's a big deal. You really get an encryption key and you encrypt everything with this, and none of the rest of these encrypt anything by default. Well, none of them encrypt anything as part of the HTTP method. Now, you might have some kind of stuff you wrote that does some kind of custom encryption, which is almost always a terrible idea, but Yahoo did that for a while. They used HTTP, and then they had their own scripts that did something like MD5 hash to password. But it's much better to just use HTTPS. In general, never write your own cryptography. Use standard libraries. If you make up your own cryptography, you are just going to discover why mathematicians exist and why you are not one of them. You think you're smart. You are not smart. Compared to the people who write cryptography libraries, it is really demanding. And the people who made HTTPS are the smartest people in the world. So unless you really think you're smarter than them, don't fool yourself and write your own crypto. Anyway, all right. So the headers are here. There's a bunch of them. Connection, I've seen a lot. I usually see connection keep alive. See, this happens a lot when we're doing the 124 class and we're writing our own Python scripts to brute force things. You make a connection, and you can then send multiple, which is the TCP handshake, SYN, ACK. You can then send multiple GET requests through the same connection, as long as they allow that by having connection keep alive. You can send up to 100 requests through the same TCP connection before you have to tear it down and make a new one by default with Apache. And that's what the connection you can control that here. Normally you leave it alone. Content encoding tells you what encoding system you use for the content, whether it's Unicode for foreign characters or ASCII or UTF-8, or whether it's zip to compress it or something, and there's a lot of versions. Content length gives you the number of bytes in the message body. Content type tells you the type of content contained there. And transfer encoding, we'll see you can use something called chunked encoding, which is mighty screwy looking. I don't know why it's there, but we'll see it. So those are general headers available in both requests and responses. Here's request headers. Accept tells it what you're willing to accept, like I will accept images and documents. Accept encoding. Authorization lets you use HTTP authentication, about which we'll talk more later. HTTP has 3 old systems of authentication. They're all quite simple. None of them are cryptographically secure, so they really should have HTTPS added to them. But in the presence of HTTPS, they're all right. So it's just plain text names and passwords with HTTPS. So then you've got things if modified and if none matched to have to do with whether your old copies of things are still valid. That's the if modified header. Origin shows you where things originate from, and it's going to come up in AJAX. We've talked about the referrer and the user agent before. The responses can have issues saying whether you allow this content to be fetched from other domains, which turns out to be a problem. The main browser security feature is something called the same origin model, and it is pretty much horrible. It, again, is something that made sense long, long ago when the web was new. You'd be talking to Yahoo, so everything from Yahoo should be kept separate from everything from Google, and that's fine, but now everything is a mixture of stuff from 25 servers, and there are so many ways to trick your browser into thinking it's at one domain when it's really at another, that it is not very effective, the same origin policy, but it still is the fundamental barrier in browser security. It's just a pretty weak barrier. Anyway, we talked about Pragma before and server. You can set cookies, and there's more authentication options here, which we'll talk more about later. So cookies are the main things you use to mark machines so you can find them again. All right, you can set it here, like you can set a tracking cookie to a random number. And then every time you send a request to that server, it will send the tracking cookie so they know what you're doing. And this is, of course, what DoubleClick invented and Google bought them, is to just put an invisible image on every web page on the web that puts a DoubleClick tracking cookie so that every time you load any page, it also sends a request to DoubleClick servers so they know everything you're doing. This is how third-party cookies spy on you totally, and it's extremely effective. And this is what pays for the whole internet. This is why we have free services. Many people have since complained, and they've said, if only we could have invented Bitcoin in 1970 and arranged to pay 1/10 of a cent for every page, then we wouldn't have all this privacy invasion. But they have to pay for it somehow. And since stuff is free, that means they have to find some way to pick your pocket that isn't as obvious, because they've got to get money out of you, and they get it with tracking cookies by spying on everything you do and targeting ads.
Yeah, and giving you what you want. You're like, oh, I really wanted that.
That's right. Well, it's amazing. It's amazing how stupid it is. If I go to Amazon and buy a pair of shoes, every page for next month tries to sell me those same shoes. Like, somebody should be smarter than that. Yeah.
So recent research actually proved that about 50% of all the transactions are made from context ads. So that means the targeted ads actually working.
Oh, that's why newspapers are going broke and magazines are going broke, because the old system was. Remember, there was a big guy, it was a Madison Avenue thing. You'd pay for models and cameras and photo processors to make this beautiful ad for something like cigarettes or Coca-Cola, and you'd play it with the people dancing around smoking, and then you would say, this will make the sales good, but you could never prove it. And Google ruined the whole thing by saying, none of this qualitative guessing nonsense. We're going to put an ad on the page, and we're going to measure how many people saw the page and how many people clicked on the ad. We're going to say 2% conversion. You show 1,000 copies, you make 200 sales or 220 sales. And we're only going to charge, and we're going to have scientific analysis. This ad works, that ad didn't work. And that totally wiped out the other model, essentially, where all ads, now you can, for the first time, you're not guessing at how effective your ad is going to be. You have hard numbers to know how much money you're getting out of your ads.
You know what's so scary about Google too is when they first started, they weren't in the ad business. Like, they did the collaborative filter, and they realized we can correlate like the amount of clicks that people add on that are reasonable, and then we can do this with advertising, and they totally switched it over.
Yeah, then this is what happened. I mean, Google and Facebook started providing a service. Google had a lofty mission to index all the world's information to basically replace all the libraries. And Facebook was just trying to help people get dates. It was am I hot or not is all it was at first. And then they both discovered that they had a treasure trove of data that would make it possible to make money from advertising. And the more they invade your privacy, the more money they make. And now you have stuff like you have to have the real name policy on Facebook. That is, they think that somehow forcing you to use your real name will enable them to connect this to all the other sources of data about you more effectively and sell more ads, which is probably not true, but anyway, they believe that. And on it goes. And anyway, so you can set a cookie, say when it's going to expire, and specify what domain for which it's valid. So if I have a cookie at samsclass.info, I can have it, or I can make it only for part of samsclass.info, like games.samsclass.info, but I can't have a cookie that came from samsclass.info that is set to be valid for yahoo.com. The browser won't let me do that because of the same origin policy. Your cookie is only valid in the domain it came from. That's how they hopefully stop people from mixing each other's data together in your browser. You can specify the path for which it's valid, but it has to be a path with your domain. And you can set it to be only transmit over HTTPS, which would be a really good idea. And you can set it to only transmit over HTTP, which is also a very good idea, so that you can't just steal it with simple JavaScript. Because JavaScript, we do it in some of the classes, you just document.cookie is the document object model JavaScript reference to the cookie, so you can have a script that fetches the cookie and sends it to a third server so we can steal it. And that's one way you implement cookie theft, so you can do cross-site request forgery and break into people's accounts by replaying their cookies. So when you send an HTTP request, you get an HTTP response. In the first line, it has a status code. So the ones are unimportant, just informational. The twos mean your request works. The threes mean you've been redirected to go try again to find that content somewhere else. The four means something went wrong. Usually it couldn't find it. And the fives mean the server crashed and the programmer didn't handle the exception. I get a lot of those with my sloppy coding. So the script didn't even finish, and whoever wrote the script was such a slob they didn't even use like try except, and it just crashed and had to hash it onto the server. A properly written script, of course, should not do that very much or at all. You're supposed to handle exceptions, but I can't be bothered. And a lot of web designers can't be bothered either. But anyway, presumably the well-paid ones do at least handle their stinking exceptions. So the most common ones, 200 is what you see mostly. 301 and 302 redirect the browser to another site. And an amazing number of people put up 302 redirects and just leave them up for year after year. If you go to gmail.com at 302s to 3https.gmail.com, it did that until about a year ago, which is extremely unsafe because someone can hijack the session before it's encrypted with something like SSL strip and get in. Now, the recent versions of Chrome have actually memorized the top 1,000 sites and whether they're secure or not. So if you type gmail.com, it will not make an HTTP request at all. It will make an HTTPS request right from the start, which is much safer. But until 1 year ago, and still unless you're using Chrome, it is much safer to actually type the URL with an HTTPS in it than to just type the name of your bank.com, because that will make an HTTP request, which will then redirect the HTTPS request, and you know that's like buying phone book from an insecure source and then making phone calls and wondering why you're not reaching the right people. Anyway, so 304 is another one saying something's not modified, so you don't need to download this. You can use the old copy. 400 is an invalid request that doesn't even fit syntax. 401 is unauthorized, saying this resource is there, but you have to prove that you are authorized to get it. So now you have to reply with some kind of authorization specified in the www authenticate parameter header field. 403 forbidden means no one's allowed to go here at all, and 404 means not found. We went there and that file or folder is not there. And 500 is, and all the 500s are these internal script errors, something clashed in a script on the server like a PIP or PHP. So HTTPS. Is HTTP sent over secure sockets layer another Netscape invention to improve the security of the web? They invented the cookie and they invented SSL. Now all versions of SSL have gone out of date and are now considered unsafe, and we're actually using TLS, the successor to SSL, but it works the same way. It just uses better cryptographic procedures. And this protects all the data with encryption, which means that nobody can steal it while it's in transit without doing something pretty exotic. It doesn't mean that it's all that well protected, though. It's still stored in plain text on your hard drive. It's still available in plain text to your browser. It's still stored in plain text on the server. And if you get into things like PCI compliance, they talk about this. There's data in rest, data at rest, data in motion, and data in use. And this protects data in motion. While it's moving, it's encrypted. Unfortunately, data at rest is still at risk if someone gets your hard drive. So if you want to protect data at rest, you need something like hard drive encryption, like BitLocker. And if you want to protect data in use, you're in deep trouble, and that's what happened to Target and many other companies. Just stealing it out of the RAM of the payment card machine is a devastating attack. There are defenses for that, but people don't bother using them. Microsoft invented a type of variable in 2004 that protects data in use. So variables placed in RAM are actually only there briefly and then erased when they're no longer used. But it's not used very often. Most people just don't think of this and leave it in RAM. Anyway, you can have proxies. Yeah.
Would it be true like the more RAM you have, the more data would be stored at rest?
Yes, I think so.
So that
to be fair, what doesn't fit in RAM ends up like in the page file.
Right.
And that's typically not encrypted either. But if you did have whole disk encryption, like BitLocker or something, it would be. So having less RAM might, in principle, be safer, but in practice, not really enough.
Because now it's like RAM is so inexpensive, people, you're like, oh, we'll get a bunch of RAM.
Well, I would too, because performance is important, and it'd be better to just write. I haven't seen anyone take any serious step to protect RAM. They've been talking a long time about encrypting the RAM, and it hasn't happened yet.
Solid-state drives?
Solid state drives are basically the same as hard drives. They can be encrypted or not.
Right.
Like an iPhone is 100% encrypted all the time, so it's much safer than Android phones that typically are not encrypted.
Right.
Anyway, so all right, so HTTP proxies are here to filter the internet. If you want to not let people play games or go to porn or do shopping or something at work, the most effective way is make them go through a proxy, so they cannot connect directly to the internet at all. They ask the proxy, please download Yahoo, and then the proxy decides if Yahoo is acceptable, and if it is, it downloads Yahoo and shows it up to them. They never get to directly connect to anybody, which is fine as far as HTTP goes. You can put a device in the middle, and HTTP won't care. However, if you have HTTPS, this won't work. That's the whole point of HTTPS. If I connect to gmail.com, Google has to send me a certificate including their key. And it has to come all the way from Google. Nobody else on earth has it except Google. So they give it to me. I encrypt stuff with Google's public key. And now when I'm sending it through the proxy has no idea what I'm doing anymore. So the proxy can't scan that stuff and decide whether my content is acceptable or not. However, the way this works with normal proxies, I learned from your book, which is kind of entertaining, if you have a proxy and you make an HTTPS request, it first makes an HTTP request. So the proxy gets a chance to decide if it likes the domain. So if that was google.com and google.com is acceptable, it will then act as a TCP level relay after that and forward the packets that it can no longer open to get you there. But it will block you from going to forbidden domains even if you start making an HTTPS request, which is kind of nice. Most companies do not find this to be acceptable security at all anymore. They want to be able to see everything and scan it for viruses and malware and proprietary data leaving. So they perform this. They perform man-in-the-middle attacks over HTTPS, which are supposed to be impossible. The security model of the web is that everyone buys a certificate from a trusted certificate authority like VeriSign or Komodo or something, and then every time you use it, you verify it with that top-level trusted certificate authority, and fakes can't get through. So if you want to read encrypted traffic with your proxy in the middle, you have to deliver certificates from the proxy with fake encryption keys that you can use to open it. And your browser will pop up warnings saying this is not coming from trusted authority. Now, the one good way to do it is to push another trusted authority onto all the browsers in your company's CA, set up your own certificate authority, and then your company's employees with the machines in the company premises you can intercept them and their browser won't complain. The way it's actually done in practice by the police and by large corporations is you bribe certificate authorities to quietly give you a root key. So the Komodo will sell you their root key, and you can now sign things as if you were Komodo. This is probably not illegal, but it's certainly shockingly unethical and deterred people a lot when this started coming out about 4 years ago. But it's done all the time. And it's one of the open secrets of the web. Like everybody knew the Chinese was hacking everybody, and it wasn't exactly admitted till 2010, but everybody in the business knew it. Everybody knows this is happening all the time. There's a convention, I don't even understand how it can exist, called Suits and Spooks, where the business CEOs meet with the espionage people. They go to a con, and stuff comes out of there. And they have the shopping list for cops. And they will sell you a man-in-the-middle HTTPS device. It looks like a router, and it has a USB drive, and it says, plug in the root certificate here, and now you can read all the HTTPS stuff. So they can get it somehow. So apparently there is some top-level certificate authority that gives it to the cops for some reason, and of course, that's weakness. Anyway, that's the way it is.
And that's just for the corporations to spy on their employees, or?
Yes. Well, you can spy on their employees. What it is so they know what's coming in and out of their network. Because encrypted tunnels like VPNs and HTTPS connections are too dangerous to put up with anymore. Everything should be examined and then re-encrypted and sent on. Very few corporations will really allow you to have encrypted tunnels because you don't know what's happening, especially since Snowden and Bradley Manning. They are very, very concerned that somebody on the premises might be doing something really bad, and it's not acceptable to just have a routine practice of people sending encrypted stuff out and we don't even know what it is.
And it's like in the policy and procedure papers. I mean, like when you sit down, they'll be like, look, this is the deal when you use this machine, or even bring your own device. They're like, we will examine your device, we'll try to respect your privacy, but
yeah,
we're going to look at what you got.
And another thing, I think this may have something to do with another thing. When you analyze mobile apps, I've done a lot of them, an enormous number of mobile apps, like 15% of all Android apps don't actually verify the certificates with the certificate authority, and something like 3% of all iOS apps. It is very common that developers just don't do that check, and then they never turn it on for the production version, because I guess they're testing their data with man-in-the-middle attacks, and that's how they implement it. Now, the right way to implement it is to import a certificate for your man-in-the-middle for that one device you're testing on, but in practice, an enormous number of apps have fake HTTPS where they believe any certificate they hear without verifying it with a third party, because the customer will never know. They go to Gmail, the page opens, they're fine. They have no knowledge of the fact that one of the major protections of HTTPS has been commented out by the developer. There's no easy way to tell.
So, and it's like the push to get it out there, like especially with apps. It's all just about like.
Yeah, so it's like they get used to doing it this way to make it easy to test it, and then just nobody thinks of it turning it back on into the production version.
Or do it in an update.
That practice is actually illegal. Fandango and Credit Karma were sued by the Federal Trade Commission, where they said when your terms of service and you say we take reasonable measures to protect your data, and then you break HTTPS, that violates it, and they actually got punished by the FTC for that. So there's some limit to how far you can go. Anyway, all right. And so HTTP authentication, basic authentication, sends your name and password encoded with base64, which is not encryption at all. It's just making it slightly difficult to read. NTLM uses Microsoft's NTLM protocol, which is MD4 hashes. Digest uses MD5 hashes. In practice, all of those might as well be plain text for all practical purposes. They're all so old and out of date and weak that there are common hacking tools that will pretty much blast through them like nothing. So
there are websites, you
yeah.
just paste the code and it's doing the decoding.
Yeah. What was that?
There's a website, you basically just,
Oh, sure.
like a Google
Yeah,
Translate, you
yeah.
just put the code.
Yeah, for base 64. The others, anyway, so these are all too easy to reverse, and so you really need to couple them with HTTPS. So this is what's on there, and then there's another layer of encryption on it that's really up to modern standards. And HTTPS is really quite strong. All right, so we've got a few more iClickers, and then we'll take a break. So, if you log into an email server, what response header records your identity? All right, guess I can quit at 25. All right, and that's of course set cookie. Your identity is stored in a cookie. You could put something in there like your password and username, but that would be sleazy. You ought to put in just a long random number that has no clue, no information about that, and just matches a random number stored in a database someplace on the server. Anyway, what request header identifies your browser? Quit at 25. All right, that's your user agent. Good. By the way, one common trick, if you go to a page and they only show you part of it and then they want pay, is you just set your user agent to the Google search bot and it'll show you everything because they want to get indexed. That's a common trick. It violates Google's terms of service, and you can see Proxies do this because when you search for something, Google saw it, so it'll come up in the hits, and when you go there, you can't see it, which is rude, but it's a cheap way to get advertising out of Google until they catch you, and then they punish you with PageRank. Google has a whole team trying to catch all these dodges and hammer them down, and then the criminals have a bunch more dodges, and the whole SEO versus the Google search bot team is the same as viruses and the antivirus companies. The cops and robbers, cops get bigger guns, crooks get bigger guns, so the cops get bigger guns, so the crooks get bigger guns, and on you go. Which one will protect a cookie from being stolen by JavaScript? And we'll do these things in a lot more detail later. You'll be doing projects stealing these things and turning on the defenses. All right, and that's HTTP only is what prevents JavaScript from fetching it through the document object model, which we'll talk more about later. And what kind of transmission resists man-in-the-middle attacks? This is important and kind of screwy because everything you send goes through a whole bunch of devices, your switches, your routers, your ISP. There are a bunch of people in the middle. I'll quit at 30. All right, the only thing there that can do it is the secure cookie. The secure cookie is sent over HTTPS, and that has this whole deal with the certificate and the trusted third party so that you encrypt it with a key that came from the end device and can't have been forged. So all those people in the middle, although they can see your traffic, they can't read it or alter it. They could block it and create a denial of service, but they couldn't read it or alter it because they don't have the cryptographic key, and that's the idea.
So does HTTPS doesn't have secure cookies as default, or how does that work?
You have to put on the secure cookie flag, or the cookie might be sent by HTTP. Now, Google just switched to everything 100% HTTPS all the time, and that is really solving the problem with a nice big hammer. But almost every other website, like Amazon, has found that to be too difficult, probably because they had ad partners that haven't upgraded. So they now have, I spent a while running through the Amazon cookies for a while. I thought I was finding too much from them, and I was going to make a big stink at DEF CON, but I decided it was kind of all right. You go to I can get like your first name and your username and like a list of products in your shopping cart without breaking encryption on Amazon. I can get a lot of stuff, but I can't actually make a purchase without going to the secure site. So their server has secure stuff and insecure stuff all mixed, which is a whole lot of extra work, but apparently that's the business decision, that's what works, and making it 100% HTTPS would foul up something else, probably their connection with peripheral businesses. Yeah,
Isn't it the same with eBay?
I think it is, yeah. Google is the only one that actually just made everything HTTPS. Everybody else is still mixing the two, and hopefully making wise decisions about what to encrypt and what not to encrypt.
So does that mean Google ads coming on there through like AdSense on your site would be HTTPS?
No, not always, I
Can't
think.
guarantee
No,
that.
but if you go to a Google site, like YouTube or Google, everything's HTTPS. But yeah, in fact, I know we'll see later, some of their APIs let you do HTTP things. They don't force everybody else to use HTTPS, but inside they do. Anyway, let's take a break till 7:10. And anybody come to ad? All right. Oh, there. Good. I'll bring up the ad codes. All right. But you already got one, I think, didn't you?
Yeah.
Yeah, okay. If anybody needs an ad code. Anyway, we'll pick up at 7:10. Let me stop this recording. This is,
You have an ad code?
yeah, Chapter 3A.